Oh, and so let's get started with as the question is there in front of you, you can see the question. So we can look at the question, and the question says that here at 200 kVA, 480 volt 50 hertz Y connected synchronous generator with a rated field current of 5 ampere was tested. Okay, so the important information you don't get bogged down by by such a big. So given data means it has been the given data is it is Y connected. Okay, so Y connected, surely that means your V line voltage would be root 3 times your V phase, correct? So V line voltage here it is mentioned is 480 volts, right? Okay, with the rated field current. So IF is given 5 amperes. Okay, and V terminal open circuit at the rated was measured to be 540. So this is V terminal open circuit. So what does that reflect? That means V terminal when you when the load is not there. So your terminal voltage, okay, that is your EA value, because see you already saw your V phase value was equal to your or your EA value in the previous question that we see. EA would be equal to V phase, okay? Then there is no armature current. So we just saw na V phase was equal to EA minus J times, okay? The equation was J times IA, okay, into XS, right? And minus IARA. This was your. But if IA value is not there, so V phase would be equal to your V terminal, right? Then another information given is there, I load, okay? That is your I line current. Now in star case, I line and I phase would be same. So that is equal to 300 amperes. That is the given data. Now you have to find the resistance. Now see here, the generator described above is basically Y connected. For the direct current in the resistance test, see, there are two windings. So with the rated field was tested and the following were taken, we measured to 440 when okay, here. So what he says, when a DC voltage of 10 volts, okay, 10 volts was applied to the two terminals. Okay, see, this is two terminals. Okay, so every terminal will be having a resistance RA. So two terminals will be having resistance 2 RA. Then a current, see, you can apply the Ohm's law there for the DC wala value. So that means 2 RA would be equal to the VDC by IDC, correct? This is the thing now. This is as per the Ohm's law. So VDC value you have, VDC is mentioned as 10 volts, right? And IDC is telling that is 25 amps. So you can get RA. RA would be equal to VDC by twice IDC. Just substitute the value. VDC is 10, 2 into 25 is 50. So that would be equal to zero point 0.2 ohms. So you got the value of RA. Now the internal generated voltage, your EA is equal to V phase open circuit. Now open circuit, this the line voltage has been given there. Okay. But your phase voltage and line voltage comparison would be this would be equal to VT divided by root 3. Why? Because it's star connected, right? So you have to calculate the phase. Phase would be equal to V line by root 3, right? So is given as V phase open circuit, which is given 540. So if you do 540 divided by root 3, you are going to get 311.8 volts. Now carefully analyze. Okay, now ISC, that is the short circuit current, that is given as 300 amperes. Okay, and now this is Y connected, so I line would be equal to I phase. So no need to change this current. Now what you need is basically, see, as the model, if you look at the model here, what we had derived. So this was the model per phase equivalent. We need this RA value, we need this RA, we need this XS value. Basically, this would be XS would be equal to XA plus X, correct? So we usually combine it like this. And here we have plus minus V phase here, and this is value is our EA value. And this is the field current, the rotor side circuit, right? Which is given IF, okay, and this is the field voltage, which is usually 0 to 400 volts, okay, RF and LF. Now, how do you get the value of this? Okay, suppose here you may get, sir, how do I get this and all that? Okay, so you just look at this circuit, right? Now, if you just short circuit this wala side, okay, where if I'm short circuiting this, obviously what is going to happen? Short circuit means voltage would be zero here. So this is the circuit, new circuit here. Okay, so this is my JXS. Okay, this is my RA, and I just short circuit my this thing IA, and here the V phase value becomes equal to zero. So in this scenario, if I just need to calculate this IA value, so just if I apply the KVL or directly if I apply, IA would be equal to how much? Tell me, IA would be equal to EA. Now this is a phasor addition there. RA plus J times XS. Okay. In the magnitude terms, you can write it as EA divided by RA ka square plus XS ka square. So this would be the magnitude of it, right? So we are interested in calculating the magnitude. Now you look over here. If you want the impedance, impedance would be equal to EA by IA, correct? Now IA value is this. So that means IA value is this. No, IA value just substitute RA in the magnitude terms. Divide by this thing RA square plus XS square. This is your uh, IA value, right? IA value. Okay, you are dividing it by EA. So if you divide this value, so you get the ZS value that will come on top. ZS would be equal to RS square plus XS square, which would be equal to EA by IA, correct? Now you note this. It is predominantly the self-inductance of the coil is predominantly inductive. So that means your excess value would be significantly greater than RA. Now, if you want to get excess, you can simply say this is your EA by IA, which is equal to your V phase open circuit by IA. Now, here, if you want to do the same with the examination with the same question, okay, so you just do the same thing with the question. So you need to calculate this. So you just do this. I just derived it. So here we can write EA by IA is equal to root of RS square plus XS square. The values have been given there. This is your, see, if you just look at the value, RA value you just calculated, that was equal to zero point 0.2, correct? XS is yet to be calculated. So XS you know, so you just do zero point 0.2 ka whole square plus XS ka square and the square root of it. EA value is 311.8. Correct. IA is given in the question, that is 300. Okay, just square the both the sides in calculation. 301.8 300 इसका स्क्वायर कर लो, इसका स्क्वायर कर लो, ये हो गया 0.2 स्क्वायर प्लस एक्स का स्क्वायर. अब क्या है, अब एक्स का स्क्वायर यहाँ पर रखो, ये आ गया 311.8 300 इसका होल स्क्वायर, इधर माइनस 0.2 का स्क्वायर, ये हो गया इसका एक्सेस हो गया, इसका स्क्वायर रूट ऑफ ये वाली वैल्यू 311.8 300 इसका स्क्वायर माइनस 0.2 का होल स्क्वायर. ये जैसे ही आप कैलकुलेट करोगे, यहाँ पर आपकी एक्सेस की वैल्यू आ जाएगी 1.02 ओम्स. ठीक है, एक तो ये तरीका. दूसरा, अगर आप देखोगे दूसरा जो तरीका है, ठीक है, इसमें हमने डायरेक्ट लिया ना, इसमें इस तरीके में हमने आर ए. अगर दूसरा तरीका डायरेक्ट भी आप कर सकते हो. डायरेक्ट तरीका ये है, अगर आप आर ए को नेग्लेक्ट कर दो, आर ए को नेग्लेक्ट करो, तो नेग्लेक्ट के टाइम पे अगर आपने आर ए को हटाया तो ई ए बाई आई ए, जो कि जेड एस होता था, जो कि होता था बराबर आर ए स्क्वायर प्लस एक्स एस का स्क्वायर. अगर आर ए को आपने जीरो कर दिया, इसमें जीरो, तो आपका सीधे मिल जाएगा एक्स एस का स्क्वायर, इसका स्क्वायर रूट, वो सीधे आ जाएगा ई ए बाई आई ए, है ना. तो इसमें एक्सेस आ जाएगा, ई ए डाल दो वैल्यू 311.8 डिवाइड बाई 300, तो ये भी आ रहा है आपका 1.04 ओम. तो ये जो तरीका है मोर रेलेवेंट है, ठीक है. तो लेट्स होप कि यू हैव अंडरस्टूड दिस क्वेश्चन very well. Thank you very much for this.